In 2014, General Motors acknowledged that a defective ignition switch could shut off the engine while the car was still in motion. When that happened, drivers could lose power steering and power brakes. Most seriously, the airbags might not deploy. The result was 124 confirmed deaths and millions of recalled cars. Mary Barra, newly appointed as CEO, faced the problem head-on. She met with the families, apologized, and changed the company's quality system. The question is, what would have happened if GM had had the tools to detect that defect in weeks rather than 13 years?
Welcome to Advanced Quality Programs with Juan Navarro. In this podcast, we're going to dive deep into the world of quality and leadership philosophies.
Industry 4.0 is the integration of sensors, data, artificial intelligence, and connected systems with manufacturing. The scientific literature defines it as the union of physical and digital worlds through technologies that make possible to measure, analyze, and act in real time. The previous industrial revolutions were driven by steam-powered machines, electricity, and mass production, even computers with automation. But this one, the fourth revolution, happens when machines no longer work, but also report what is happening. A lathe that detects temperature increase and alerts the system. It's a clear example of this kind of technology. Industry 4.0 can be summarized in 3 steps: capture data, connect it, and use it to make decisions. Imagine that your body is a factory. The IoT sensors are your senses: touch, vision, hearing. The artificial intelligence is your brain, the thinking part. The robots are your muscles, your skeleton, and the digital twin is that virtual copy of your machine, of your production line, that allows changes to be tested without affecting the real operation of your body. Studies show that digital twins help to predict failures, improve traceability, and accelerate decisions. Now, let's return to our case study, the GM case. Some engineers had known about the defect since the start of production, since 2001, but the information remained isolated. Warranty data was not connected with the accident reports. The company had information but lacked the connection between areas, and that was part of the problem. In the today environment, with Industry 4.0, that scenario would have been different. Sensors would send real-time data, artificial intelligence would detect failure patterns, and quality dashboards would alert teams to deviations. The defect would not have lasted those 13 years. A real case in medical manufacturing shows actually the same point. One company reduced its root cause analysis from 6 days to 4 hours, all thanks to that connected sensors and data. This type of improvement aligns with studies on predictive maintenance and digital twins. Today, companies that adopt the Industry 4.0 report significant improvements according to McKinsey and their analysis. The digitalization of industrial processes can actually reduce downtimes by 30 to 50%, increase the productivity by 15 to 30%, and improve quality by 10 to 20%. These ranges align with academic studies documenting similar improvements in efficiency and failure reduction. These figures are not theoretical. A 50% reduction of the downtime means that a machine that used to be stopped for 200 hours per year now stops around the less time, 100. And those 100 recovered hours became real production, revenue, and operational stability. In quality, for quality management terms, 20% of improvement can be a difference between profitability or loss in industries that have tight margins. But here's the key point. The Industry 4.0 is not about installing screens or about having a decoration in your plant. It is about using that data on your screen to decide. I have seen factories with huge dashboards that no one consults. Not digital transformation as we know it. That is digital decoration at Christmas tree all year long. But transformation really happens when an operator can adjust a parameter after seeing the alert, or when a manager acts before the problem reaches the customer. GM did not fail because of a lack of data. It failed because of a lack of connection between data and decisions. The idea that those who are about to adopt are the best fit to survive is reflected in Mary Barra's decision, which began by changing the company culture, not just the processes. Industry 4.0 is not a fad, but without a culture that listens to data and acts, technology is useless. Then your job as a leader and as a operational excellence professional is to close those gaps between what you know and what you do. Industry 4.0 is not a threat, it is an opportunity to prevent cases like the one from GM from happening again. And that's all for this week. If this episode made you think, please share it. Maybe it will help that colleague that thinks that quality is only about filling forms. Thank you for your ratings to my books, The Principles of Quality, Life Quality Projects, and the Quality Mindset. Without further ADO, stay excellent, keep improving, and it's time to digitalize.
One small change triggers everything. Watch how agile thinking works. Inspect, adapt, repeat. Each step builds the next, creating confident, unstoppable momentum. This is the Quality Mindset by Juan Navarro. Get your copy now.